up, Dr. K? My name is Sarai Soka and this is my Gait Cycle presentation. Gait Cycle is divided in two phases. The first one is a stance phase, which is 60% of the Gait Cycle, and swing phase, which is 40% of the Gait Cycle. At initial contact, the line of gravity will be anterior to the hip and knee and posterior to the ankle. The ankle range of motion will be 0 and the knee range of motion will be 0. And at the hip range of motion, it's going to be 20 degrees. During initial contact, the glute max along with hamstrings contract concentrically to extend the hip and prevent uncontrolled trunk flexion over the femur. The glute remains active from initial contact to mid-stance to extend the hip and move the body forward. The knee is stabilized by eccentric quadricep activity and ground reaction force from gastrocnemius and soleus, and anterior tibialis works eccentrically to prevent the foot from slapping on the ground. Foot flat, the line of gravity will be anterior to the hip and posterior to the knee and ankle. The ankle range of motion is going to be 5 degrees of plantar flexion, 15 degrees of knee flexion, and 15 degrees of hip flexion. During foot flat, the glutes and hamstrings remain active, as I said before, to extend the hip and move the body forward. The quads contract concentrically to extend the knee and support the weight of the body during mid-stance. The plantar flexors contract eccentrically to control the forward movement of the tibia and fibula related to the talus, and dorsiflexors contract concentrically. At mid-stance, the line of gravity is posterior to the hip and anterior to the knee and ankle. We are going to see 5 degrees of dorsiflexion, 5 degrees of knee flexion, and 0 degree at the hip. During mid-stance, the psoas works eccentrically as the hip is extending at that time, followed by a concentric action to initiate hip flexion just before toe off. And the plantar flexor works concentric. At heel off, the line of gravity is posterior to the hip and anterior to the knee and ankle. The range of motion is going to be 0 degree at ankle and knee and about 10 to 20 degrees of hip extension. During heel off, the hip flexors work eccentrically as the hip is extending at that time. The major burst of activity of the ankle plantar flexors occurs near heel off and decreases rapidly to near 0 at toe off. During this brief period, shortening of the muscles creates an ankle plantar flexion torque that participate in the forward propulsion of the body. At toe off, the line of gravity is posterior to the hip and knee and anterior to the ankle. The ankle range of motion is 20 degrees of plantar flexion, and knee range of motion is 30 degrees of flexion, and the hip range of motion is about 10-20 degrees of extension. During toe off, the hip flexors are going to contract concentrically to initiate hip flexion. Quads are going to work eccentrically and dorsiflexors work concentrically. The peak activity of the dorsiflexors happen at toe. The phase of Gait Cycle is the swing phase, and we are going to start with acceleration. During acceleration, the ankle range of motion is going to be 10 degrees of plantar flexion, knee 60 degrees of flexion, and hip 20 degrees of flexion. During acceleration, the key role of the hip flexors are to advance the lower extremity forward during swing in preparation for the next step and to lift the lower extremity to allow for toe clearance during swing. The quads are going to work eccentrically and the dorsiflexors concentrically in order to clear the toes from the ground. Mid-swing, the ankle range of motion is 0 degree. The knee range of motion is 30 degree of flexion, and hip range of motion is 30 degree of flexion. During mid-swing, glute activation is needed to first decelerate the flexing knee and then initiate its extension. Isometric contraction will be seen in the dorsiflexor. As swing phase is deceleration. Ankle range of motion and knee range of motion is going to be 0 degrees. And hip range of motion is going to be 30 degrees of flexion. Glute max and hamstrings works eccentrically and dorsiflexors isometrically. We are going to talk about frontal plane range of motion, and we are going to start with the hip. The standing hip goes to 5% of abduction from 0% to 20%, and then it moves into abduction of the hip at 60%. This is accomplished by gluteus medius and quadratus lumborum. It goes to 7 degrees of abduction at 70% of the gait cycle. When you contact the ground, you go into eversion moment with pronation, which creates pliability, which is very necessary until heel off, which is 40%. Then we see a spike activity going to inversion of the foot, so the arch is becoming stiffer. So during heel off and toe off, you have a stiff foot and wingless mechanism working in order to push yourself and propel yourself off the ground. The lumbar gait is an excessive pelvic drop during the swing phase due to the contralateral glute med weakness. The trunk deviates laterally towards the stance phase as a compensation. Gait. Affected side during swing phase, possibly due anterior tibialis weakness, spastic plantar flexors, or plantar flexors contracture. An excessive hip flexion during swing phase could be a compensation.